So what if I give you a couple of equations that look like this and asked you, well, are these things parallel or perpendicular to each other? Well, how do we do this? Let's go back and review first. If you remember correctly, parallel lines are what I called vegetarian lines, right? They go on forever and they never meet. Get it? Vegetarian meat? Never. Okay. Anyways, if you look at this, look at what happens. The slopes are the same. They're the same. The only difference is they have a different y-intercept. That's what this is trying to tell you. It says the lines have the same slope but different intercepts. Now wait a second, wait a second, wait a second, wait a second. How does this compare to our new formula? Our y equals to mx plus b stuff. So if we call this equation 1 and this one equation 2, look, they're both in y equals to mx plus b format, which now that becomes incredibly important. If it's not in y equals mx plus b, put it in y equals to mx plus b. But if you do, check this out. If they are parallel, those two slopes are the same. That's what it's telling you. Those two slopes are the same. So if you look back here, let's look at this. Look, those two slopes on that equation, not the same. Guess what? They're not going to be parallel. Look at these slopes. These slopes are the same. Guess what? Those will be parallel. Now, we'll worry about this one after, okay? Now, what's really, really important too is how can you tell something's perpendicular? Remember, perpendicular is a line that meets at, boom, 90 degrees like that. So there's one line, there's the other line. Now, remember, how do you remember what the slopes look like? The slopes have to be negative reciprocals of each other. Do you remember that? What that means? So if I had a slope of 1/2, a negative reciprocal would be flip it and make it a negative. Dunk. There we go. And that's how you do it. Even if this guy was a slope of something, let's say, like -3. Well, remember, that's 3/1. Flip it, that's 1/3. Make it, and change the sign of this guy, make it a positive, and you're good to go. So that's kind of important to realize. So again, it still has to be in, guess what? Y equals to mx plus b form. If it's not in y equals mx plus b form, how can you figure out the slope? You can't, and then you don't know if it's perpendicular or not. So let's go to these questions here. Let's look at this original one here. We've solved this one, so we don't even need this one anymore. But we want this one here. Are the slopes negative reciprocals of each other? Oops, sorry about that. Are the slopes negative reciprocals of each other? Look at this. There's a 2. There's a 1/2. Yes, they're reciprocals, but in order to be perpendicular, that would have to be negative. So no, this is not perpendicular. It's not parallel. They're just two separate lines. Now, remember this complicated one over here? Let's clean up some room here and let's give us some workspace. Okay, so the whole point of this is to make sure we've got it in y equals mx plus b form. This one's good, okay? But what about that one? Ugh, rats. Okay, so let's take it over here. 5x plus 2y equals to 8. Let's put it into y equals mx plus b form. Let's subtract the 5x from both sides. Got it? Perfect. That's gone, leaving you 2y equals to minus 5x plus 8. So we're close. We're almost there. Let's keep on doing the algebra here, and let's solve this. So we want it as y equals 2. If we want something as y equals 2, we get rid of the 2. Divide this by 2. Divide that by 2. That's gone, leaving you y equals to minus 5/2x plus, don't forget, 8/2 is 4. So you have to divide both elements. Now, there's our slope, minus 5/2. Let's compare it to the other graph. Minus 5/2, and look at this. Look at this, 2/5. So 2/5, negative reciprocal becomes minus 5/2. These guys, in fact, are perpendicular to each other. Ha-ha! So that's how you do parallel and perpendicular lines using y equals mx plus b.